So in this video, we'll learn about distance. So let's say if we have two lengths. So let's say if there's a point A and there's point B, which is 5 meters away. And then from B to C, it's 3 meters away. Now, if we want the length of A to B to C, so basically the length from A to C, we can do this. AC is equal to the length AB plus the length BC. And we put in the numerical value, we'll get 5 plus 3, which gives us 8 meters. Now, what if this length is on a triangle? So you're moving in two directions. So there's A, B, and C. And we are moving 5 meters over here and 3 meters over here to reach point C. So you move this way and then this way. So you're eventually reaching point C. But then there's an alternative way to get to point C from A, which is the direct path from A to C. So let's say if this is a right angle triangle, 90 degrees over here. How can we find AC? So we'll discuss this in more details when we do the Pythagoras' theorem, but right now I'll give you the theorem so that we can work on this question. So what does Pythagoras' theorem say? So Pythagoras' theorem says if you have a right angle triangle and you have two sides named A and B, you can give it numbers or give it any value. Right now we are treating A and B as a number or a value or a variable, however you want to describe it. And C is the third variable. Now this side opposite the right angled triangle or the right angle is the hypotenuse. This is the hypotenuse. So Pythagoras' theorem says that if you square this hypotenuse, it is always equal to the sum of the other side individually squared. So this is what it's saying. So if I take C squared, it's equal to the square of A and the square of B. So for instance, if I have to find this value, let's call this C once again. Now the theorem is saying C squared is equal to A squared plus B squared. Now we want to find C, so we'll keep this as it is. We can describe AB as A or B, it's up to you, whichever letter you want to use for it. Let's use A. So if this is A and AC is C, then let's take BC to be B. Okay, let's plug in these values. So A is 5, so in place of this I'll put a 5. So this becomes 5 squared. And B is 3. So over here I'll put a 3. So 3 squared. Now we can use our calculator, or we can solve the value of 5 squared. So 5 squared is 5 times 5, which solves as 25. And similarly 3 squared is 3 times 3, which solves to 9. Let's plug in these values, 25 plus 9. When we add both the values, again, we can solve all of this on a calculator. So we get C squared is 34, but our question is find C, not C squared. So let's use SADMAP. We see an exponent. What's the opposite of the square? The opposite of square is square root. So let's take the square root on both sides. So this becomes c, and this becomes the square root of 34, which, when we solve it on a calculator, we will get 5.83. So this length C is 5.83. So whenever we have an incline like this, we can use the distance formula using the Pythagoras theorem. Now what if you have a graph and a point over here and a point here? So let's create our own coordinates. So let's say this is 2 and this is 4 and maybe this is 1 and this is 5. So let's make our right angle triangle. So what is the distance from 2 to 4? 2 units. So this length is 2 units. And then what's the length from 1 to 5? It's 4 units. So this is 4 units. So now we have a right triangle with 2 over here and 4 over here. We want this length. Let's call it AB. So we want the length AB. So we'll use the Pythagoras theorem again. Pythagoras' theorem says c squared is equal to a squared plus b squared. So this is a, this is b. Let's plug in the values. So we've got a as 2, and we have b as 4. And we plug in, get 20. So c squared is 20. But we want c, so let's take the square root on both sides. So c is equal to the square root of 20, which solves to 4.47 units. So this length c is 4.47 units. Lastly, what if we use that same graph, but this time we name them in terms of x? We want this length. Let's say if this point over here is x1 and this point is x2. Remember, these are notations, not exponents. Exponent is when the 2 is written in the superscript. This is written in the subscript. And let's say if this point is y1 and y2. Let's make our right angle triangle. We obviously are looking for this length, right? So when you have values, how do you find this length? You subtract x2 and x1. So if we were just to copy that idea and that logic, we'll just write it this way. And similarly, if you want this length, we'll subtract the larger value, which is y2 and y1. So we'll get y2 minus y1, right? So now we have a right triangle that looks like this, with sides x2 minus x1 and y2 minus y1. So let's define this as A, let's define this as B, and we are looking for C. So now you can have numerical values or an expression. Use the Pythagoras theorem. So c squared is equal to a squared plus b squared. Now let's plug in everything. What is a? A is right here. Let's put that in the spot. So x2 minus x1. And we want to square it, right? Then we have a plus. What is b? B is right here. Y2 minus y1 whole squared. And we need c. We don't want c squared. So how would we find c? You take the square root on both sides. So c is equal to this is a formula you need to remember. So in summary, we have a few things that you need to remember. For length, if you have two lengths like 3 units plus 1 unit, that can be miles, kilometers, meters. The total length is the sum of these two. So total length is equal to 3 plus 1. Whenever you have an incline, we'll make a right triangle underneath it. And then we'll define these two sides as A and B. And we'll define the length we want as C and apply the Pythagoras' theorem. So we get C squared is equal to A squared plus B squared. You apply this theorem and we'll always get the value of C. Sometimes you'll have variables, sometimes you'll have values. And that is what we need to find the distance.